Okay, so welcome everybody. This is our next. I'm really excited for this webinar. This is our fourth one now, I think, in our series. And so, if you've been involved in any of the previous webinars, you'll know that this is part of our Teaching Innovation Awards. And with our Teaching Innovation Awards, we are looking for digital innovators, essentially. And not only are we interested in supporting those people who partner with us, but we're also really excited to showcase people's works who don't partner with us, but just demonstrate just really good teaching strategy innovation, teaching and learning strategy innovation. It's really important at the moment that we all try and work as a community, I think, to try and share best practice. Sometimes when you're working in your own institution, you don't often get the opportunities to see what's going on outside. And sometimes even just small practical changes can have a big impact on not only your satisfaction as well, but obviously student satisfaction and achievement. So my name is Leanne Williams. I'm a professor of life science education at the University of Warwick, an academic lead here at LearnSci. And so I'm delighted to host this webinar today with with Ben. I'm not going to talk too much. I'm not going to introduce Ben too much. So hopefully, Ben, you can introduce yourself the way you want to, and lead into then talk a bit about why this project started, what your inspiration was for the project, and so on. Bit of housekeeping rules then for everybody. If you join in late, please make sure that your microphones are off. We will be monitoring the chat throughout the talks. If there's anything that pops into your mind that you want to just write down and ask a question, I can then ask that to Ben at the end. If you're feeling brave and you're okay with having your video on, please do so and raise your hand if you want to ask a question, and then I'll invite you to ask a question ask your question directly to Ben. For those of you that are interested in our Teaching Innovation Awards, if you've been inspired by any of these talks, or in fact, if you think that some of the things that you're actually doing in your day-to-day are actually good for case studies or case scenarios that you could actually put forward, that the rest of us could learn from, then please go to our website, have a little look at some of the previous applicants, the winners, and so on, and then get in touch if you want to find out any more information. And if you want to find out any information about the educational research that we support and that we get involved in, again, some of these projects are definitely suitable for publication, and so if you're not sure where to start, just let us know and we can help you with that. So please, again, go to our website and have a look at what we've done to help other people get past that. It's important, again, for us to all support each other in our careers as well as showcasing excellent work. And so that's it from me. I'm pretty sure I've forgotten to say something really important, but I might then try and add it in at the end if I do remember. Otherwise, I think that's, I'm going to hand over to you now, Ben. We'll have about half an hour or so or more. We've got plenty of time today for you to go through your talk, and then we'll open up for discussion and questions at the end. So over to you, Ben.
Perfect. Thank you very much, Leanne. Can everybody hear me okay?
Yes.
Good. So thank you for joining the webinar this afternoon, just gone. So my name is Ben. I'm a lecturer in physical chemistry education based at the School of Chemistry at the University of Edinburgh. And it's a great pleasure to be able to join you all today to share a little bit about a project that we've been running over the past couple of years, using the LearnSci, a bespoke suite of LearnSci smart worksheets. So we're going to be talking about their use in a second-year physical chemistry lab course that I've been running since 2023. But to kind of start off and give a little bit of background, I wanted to share some things. There we go. Share some things that some of the students said to me when I first arrived at Edinburgh, and these are things that I've heard from other students at other places, and these are maybe familiar to you from your own institutes as well. So some anecdotal quotes there from students who think that there were too many lab reports in this particular lab course, that they spent a lot of time gathering lots of numbers, but they didn't fully understand how to perform the data analysis that was being asked of them. That the students were spending a lot of time writing lab reports, and that they, after spending that effort writing these lab reports, they were finding that they were waiting quite a while to get marks and feedback on them. And I'll maybe add a staff quote or a staff anecdote as well to kind of back up the student's point of view here, is the notion that we were spending quite a lot of time and money marking weekly assignments. So students coming to the lab on a weekly basis and turning something in or submitting an assessment on a weekly basis. And so this, along with some other factors, kind of allowed me to think about a different way forward, and this involved using what I've called the worksheet intervention. So this was the curation of a set of bespoke smart online worksheets in collaboration with LearnSci to use in this physical chemistry lab course, which is a component of our Chemistry 2 module. So for a bit of academic context, Chemistry 2 is a year-long course. It's our standard course for our second-year chemistry students. That's a SCQF level 8, so about level 5 for the framework that's used across the rest of the UK. And with it spanning across both of our semesters, we have a lab course component that is split into 3. So our students visit on a rotation basis the inorganic chemistry laboratory, the physical chemistry laboratory, and the organic chemistry laboratory. So we're going to be focusing on this lab course here that spans the last 3 weeks of semester 1, the first 3 weeks of semester 2. And I took over the course in academic year 23-24. So before I took over, the students performed 6 experiments, 1 experiment per week, and these were assessed through a long lab report, or a traditional lab report that runs from abstract, introduction, methodology, results, discussion, conclusions, and so on. In academic year 23-24, I changed the format such that students would write 2 long reports and 4 short reports. And so I replaced 4 of these longer form reports with 4 short ones that really concentrated on the results in the analysis and the discussion of those results. So trying to really focus down on what students were obtaining from the lab and then what they were doing with those numbers afterwards. After some discussions with LearnSci that started after a meeting at VICEFEC, that's the Variety in Chemistry Education and Physics Higher Education Conference in 2023? Oh my goodness, I don't remember. One of those years. That transitions then into academic year 24-25, when those 4 short reports were then replaced with our bespoke suite of online worksheets. And I've written 24-25 plus because they've been continued to be used over the past academic year as well. So taking those curated worksheets and then continuing their use over the next few academic years. So if we think about what it is that we wanted to do with these smart online worksheets, we wanted to take the essence of these short reports that were replacing these more longer form reports and really focus in on data, analysis, and on discussion. So a number of guiding principles here that I've jotted down that kind of helped steer how we designed the worksheets in collaboration with the development team at LearnSci and the capabilities of the worksheet environment. And I want to just kind of zone in on a couple of those guiding principles. So the first one, other than the focus on the student data, was an ability to assess the quality of the student data. So to really answer the question, are the students performing the experiment effectively? So one of the ways that we did that, and we'll see a little bit later on how that was done, was to introduce what I've termed boundaried marks. So most, if not all, of the experiments in our second year Phys Chem module require the calculation of a number. So the enthalpy of a vaporization, a critical micelle concentration, a particular conductivity, or a particular rate constant, for example. The last one is a gas chromatography experiment, so it's a percentage weight of a component. These boundary marks allowed the worksheet to compare a student-derived answer with initially a literature answer, and then look at how the students were performing the experiment and kind of extrapolating the effective performance to the number that they managed to calculate of the particular parameter that they were interested in. The assessment of the quality of student data then actually came from, rather than a comparison to a literature value, but actually a direct comparison between the student-derived answer and the derived answers of the cohort that performed the experiment the year before. And that meant that the quality of student data and that final answer was being assessed against previous experiments that were performed using the same setup. So it was no longer a comparison to just a literature value, but it was a comparison to a value that had been obtained from years previous using the same equipment, the same chemicals, and the same conditions. We also wanted to personalize some of the questions, so really pushing the conversation to how to perform a calculation rather than what the answer should be. So I had a vision of students who were maybe working through the worksheet together, and having a set of questions that meant the students' conversation were steered away from, I've put 3.2 and I've got the right answer, so you should also put 3.2, to more of a procedural conversation where students could talk about dividing by a particular concentration or thinking about a particular absorbance reading in order to get an answer that was specific or personal to them, but whose procedure could then be peer taught to others. We wanted to think about the breakdown of the steps of the data analysis, in particular around the anxiety caused by mathematics, and maybe not mathematics specifically, but I guess more generally long-form calculations. And also thinking about the link between the number and the explanation. So thinking about discussion questions and extension sections that allowed our students to think about the chemical and physical processes that were behind the number. And we'll see a couple of examples of those in the next slide. But those are kind of the guiding principles that allowed us to think about what we wanted our conversion of those short reports into these online worksheets, what we wanted that conversion to look like. So this is an example of one of the worksheets that was designed. So this is based on an experiment that uses the Beer-Lambert law. So there were two parts to this experiment. The first part is to construct a Beer-Lambert law calibration graph to calculate the concentration of an unknown. And the second part is using the Beer-Lambert law, but with a gas sample, to think about calculating an enthalpy of vaporization. So using a Beer-Lambert law type expression to be able to do that. And you can see on the right-hand side there some of the things that the worksheet has asked the students to actually perform. So there's a data input and quality part. So that's this part here where we have our calibration curve data of our standard concentrations and our absorbances at particular wavelengths. Along with the input of data then, our worksheets include a graphical interface that allows our students to be able to draw or construct a graph, and then to be able to use that graph. So particularly here to do a calculation of the concentration of an unknown. Use that data then to calculate something that's unseen. Do a similar analysis for an experiment that is slightly different. So that's the enthalpy of vaporization experiment that I talked about. Performance of those uncertainty calculations, but in a way that is broken down and leads the student through each of the various steps, so they have an understanding of what that uncertainty calculation actually involves. A quite extensive discursive section, so the students can begin to appreciate some of the meanings behind the numbers that they're calculating, what does the enthalpy of vaporization actually mean, that number that they calculate, what goes into considering what that number means, and can we think about some of the chemistry and the physics behind that number. And then just at the end there was an extension section that kind of allowed the students to think about doing a similar experiment, but with a different chemical sample. And so allowing them to think about some of the factors that would need to be optimized or changed in our experimental procedure in order to accommodate that new chemical sample. And so in order to think about how effective these worksheets were, at the end of the first year of implementation, I performed a short survey research study to think about the student perception of these worksheets, particularly in relation to lab reports, and then thinking about the student perception of using these smart worksheets more widely in our practical chemistry courses, and also thinking about the reasons why they thought that. So this was a completely anonymous survey. It was run as if it was a chemistry education BSc or MChem research project. So the whole design of the project went through ethical approval. Our anonymous survey was distributed through our virtual learning environment, through emails, through me standing in the lecture theatre waving QR codes around. And we got about a 20% response rate for this survey, which is, yeah, perhaps a little bit on the low side for me personally. I think I would have liked to have got a bit more of a higher response rate from the students, but we got lots of good qualitative data that allowed me to delve into the responses that kind of gave a really good picture of how those students were perceiving the worksheet intervention. So if we think about the student perception of the worksheets, what I've shown you here in blue are kind of the broad themes that I managed to pick out from the qualitative answers to that survey. And then what I'll show you in the next slide in red are going to be some of the specific quotes and some of the specific points that students brought up. So in terms of thinking about the student perception of the worksheets, we can see that they're generally liked. Students thought they were effective in helping them learn chemistry and learn physical chemistry. They liked the immediacy and the usefulness of the feedback and the marks that they were getting. And they thought that they had a lot of logistical advantages as well, in particular around the perception of workload. So if we take a look at some of the very specific quotes that students were giving me, so they were the worksheets were overall enjoyable, challenging, and informative. They appreciated the guidance on the error calculations, that they were able to think about the analysis maybe in ways that they wouldn't have if they were left to their own devices. They appreciated the quick feedback for those calculations and thinking about those quantitative skills that they were learning throughout the worksheets as well. The instant feedback and the fact that it was the worksheets were marked as the student went through each of the sections was also highlighted. And then I've got a quote there about some students who felt slightly pressurized actually to think about the answer in the exact moment of doing the worksheet. What I've made clear since then actually is that students are able to save the worksheet, come back to it later, finish it in their own time. This is in essence, it's a post-lab assessment. Some students do actually on their computer or on their iPad or tablet computer have the worksheet open in the lab, so they're directly inputting data into the worksheet and coming back to finish the calculations later on. But since that comment, I've made it much clearer that students can come in and out of the worksheet as and how they wish in order to be able to relieve that slight pressure. I'm a physical chemist by training, so we like chemistry, we like physics, and we like maths. So as wonderful as the qualitative data is, I couldn't do the presentation without a little bit of quantitative data. So here's a little collection of the responses to some of the Likert scale questions in the survey there. So in particular around making the steps for data analysis clear, making the steps for data analysis easy to perform, and increasing confidence in drawing conclusions from the results that the students were obtaining. And we can see here the very dominant response being agree, split across our slightly and strongly agree there about that advantage of the worksheets, particularly in that link to those data analysis steps that we were really aiming for. If we think about the student perception of the worksheets versus lab reports, then we've got some themes that range from personal and emotional advantages. We've got some academic content advantages, those logistical advantages, in particular about that workload as well. And so we can then delve into some of those more specific quotes. So the worksheets in comparison to the traditional lab reports as being less daunting, and so allowed the students to really perform their assessment with more confidence. The worksheets were much less stressful than the traditional lab report, and having a lot, not all, but a lot of the worksheet language laid out already allowed our students to really concentrate on the process of data analysis and thinking about what those results meant, rather than thinking about the formalities of structure and grammar and language that might have held some of our students back, particularly in terms of their workflow or their confidence. So that last comment there in red about the worksheets being helpful for really helping to think about some of those points more concretely. Our academic content advantages included kind of drawing those parallels between the theoretical aspects and the practical aspects a bit more easily, and that logic behind carrying out those analysis steps. So really following it from the results that the student gets from the experiment all the way through down to the final result. If we think about those logistical advantages, then that's the one I've mentioned a couple of times already, is that perception of the workload. So not having to rush to write a new lab report every week was noted quite effectively, or was noted as being quite effective by our students. But of course, there were some students who kind of questioned their ability to remember some of the things that they covered in a worksheet compared to how they might have experienced it in a lab report. So this particular quote here, that the worksheets didn't sear the knowledge in their brain afterwards, compared to a formal lab report, which sometimes I feel I'll remember for life. So as a proponent of lifelong learning, I guess it's interesting to hear that students feel like they remember what they cover in a lab report more, but I guess I will leave it to you to decide whether this was meant in a positive or more of a colloquial manner. Yeah, searing physical chemistry into youngsters' brains is the aim, right? It's the aim. Okay, if we think about wider use of these online worksheets in practical chemistry courses, the students were really astute at picking up the fact that they would be really helpful for numerical-based experiments in practical courses. So an understanding that this fit really well into a physical chemistry lab course, that they were effective for learning and that they should be used more. But what I guess I was quite encouraged by was that they resisted the notion that everything should be replaced by the worksheets, with the understanding that they realized that they still wanted to be able to practice and hone their academic writing skills, in particular in the context of practical work, and thinking about the need for them to be able to do that in their BSc project reports or their MChem project reports at the end of their undergraduate degree. So really seeing the advantages of the worksheets, but then using them in conjunction with some of our more traditional assessment methods. So we can see here that notion that they should be used more widely in physical chemistry and for more quantitative experiments, but they shouldn't replace lab reports completely. Because they understand the need still to be able to have some outlet to be able to work on their academic writing that is connected to practical work. So just to quickly summarize on that then, students perceive the smart online worksheets relatively positively. So I loved the online worksheets is the quote that I've picked out there. That they are much more enjoyable and less stressful than the traditional full lab report, but that the full lab report still has its place. So the smart worksheet should be used more, in particular in the context of quantitative or numerical based lab courses or experiments, but remembering that writing a lab report or writing things that are based off of practical work that has been performed is still quite a fundamental skill. And so that realization that should be swept off the table completely. Some of the other points that I mentioned, particularly in terms of the guiding principles and some of the things that I showed you on that worksheet are noted here as some lessons that I learned, particularly after that first year of implementation. So those smart individual questions that I really wanted to try and push the conversation from what is the answer to how did you get the answer, I think are really useful for testing skills. But the students, at least they didn't report talking about them in that way as much as I thought. So whether that's they didn't do it or they've just not reported that they've talked about it, I had a feeling that was going to be a bit more impactful than maybe it was. And so I think there might be an onus on demonstrators and me as course instructor to kind of nudge them more towards some of those more collaborative conversations around the data analysis procedure to try and encourage some of those conversations. I had quite a few questions sent to me directly about the marks that students got for those comparisons between their calculated value and the value that was obtained initially from literature, but actually what turned out to be then numbers that came from previous years. So for me, a bit more clarity in terms of explaining what those boundaries marks, what they were and how they were calculated. Embedding resources into virtual learning environments that you are signposting students to is a much more reliable way of getting students to work with external resources than it is to ask them to go and find something, particularly if you have a resource that is tied to your institute's access to a particular journal. So that was a personal lesson for me there. And then what we've moved on to in that second year of implementation is to include more signposting in those worksheets, more specifically to the traditional long lab report format, such that students still get a feel for how what they're doing in the worksheets can be correlated, if you like, or can be compared to the traditional assessment, just to make sure they have an understanding of which bit's a result, which bit's a discussion, and really thinking about building those skills in, okay, if I then have to write a lab report for my next lab or for a similar lab, what are the bits and pieces of what I did in a worksheet that would allow me to construct a better lab report. And I just wanted to mention then, in terms of those lessons learned as well, is that with the bespoke suite of worksheets that were developed by LearnSci comes also the LearnSci Analytics dashboard, which allows me as an instructor to go into the background, if you like, and to have an understanding of how students are performing, not only on an individual basis, but on a worksheet basis. So picking out particular questions, particular areas, or particular topics that students are either not answering very well or are using the auto-solve function quite a lot on. So these are some of the lessons that I've managed to pick out from each of our bespoke worksheets. So the letters here that you see are the codes that we use that are abbreviations for each of our experiments, basically. So our Beer-Lambert law experiment, our rates by visible spectroscopy, our determination of the critical micelle concentration, the determination of a dissociation constant of an acid, and our gas chromatography experiment. What the LearnSci Analytics dashboard has allowed me to do then is to gather student data on what is being answered well and what is not being answered well. And so these bullet points under each of the experiments then has allowed me to come up with a list to take to my demonstrators who do the day-to-day hands-on teaching and say, students are really struggling with standard deviation calculations or identifying the equivalence point from pH saturation graph. Please, in the session, can we pay particular attention to some of these points at the important parts of your experiment? And so this is allowing us then to really tailor our teaching based off of the lessons learned from last week's group or the year before's group, to really think about how do we plug the gap between what our students are doing in the lab and what they're learning and how they're performing in the post-lab assessment. And then just to finish off, the bespoke smart worksheets for the physical chemistry lab and chemistry 2, that sits here. But we have a range of different ways in which we're using LearnSci throughout the School of Chemistry. So we have another set of bespoke smart worksheets for our biological chemistry courses in our first year and also in our second year. So I have colleagues who have developed those worksheets alongside LearnSci as well. And we are LabSims users. So LabSims throughout quite a number of our courses and used quite heavily in our whole school safety course, which is done by all of our undergraduate students across all 5 years of our undergraduate and our postgraduate taught students as well. So I hope that's been insightful. I hope that's given you a flavor of some of the things that I've been doing with the smart online worksheets, in particular in the physical chemistry lab course that I run, and maybe gives you some inspiration for some of the things that you might do in your own courses. So before handing back over to Leanne, I'll just mention some words of thanks. So that initial development project that kind of got us off the ground running in terms of thinking about that development was funded through the School of Chemistry here at the University of Edinburgh. A special thanks to Jason, who took what I wanted the worksheets to be and made them into what they are today, through that development process, and to everybody who tested the worksheets. So I had a batch of undergraduate students who had completed the lab course the previous academic year when they didn't have the luxury of the slightly lower workload, and PhD demonstrators as well, actually, who were the real experts in each of those experiments. And the data analysis procedures to really unpick what needed to be in the worksheets and how the worksheets performed. And then to you for your kind attention. Thank you very much.
That was brilliant. Thank you so much, Ben. I really enjoy the structure of your talk and the way you put it all together. It's a really great way to understand, for us to understand the issues that you were trying to solve in the first place and how you went through that. And it's a really, really honest reflection of what was great and what wasn't, so what could have been improved upon. And one of the things I really love is when you get students, when you ask students their opinions, because actually they're really honest about things and they actually really know what they need to use to learn. And as much as we, like to sort of promote the digital resources, they are to help support, and they're never to replace key skills, particularly things like scientific writing is still a skill that we know students struggle with. And it's really nice to say, just to see that students are aware of that and they still really need to master that skill. But I do think the way that you've gone through that supports the fundamentals first by the understanding the analysis, because then the writing comes, doesn't it? I think on that. So I think that's really, really great.
Yeah,
so thank you so
absolutely.
much.
I will just mention that in the context of the lab course that I run, students actually have access to all of the worksheets, even if they don't have to write, even if they don't have to complete the worksheet for that particular experiment. So an experiment where a student has to write a lab report, they can still be guided by the content of the worksheet that is specific to that experiment. To really kind of, marry those two things together, that focus on the analysis using the worksheet, but then the opportunity to still use that in a formal lab report to be able to work on those writing skills.
And I think that's really valuable, particularly when we have to scale up with numbers. Sometimes we just can't always give students that more one-to-one guidance that we need when it comes to doing analysis and so on. So that's really useful. Just one more question that I have, and then I'll open it up to other people. So if other people can think of their questions or write them in the chat, that'd be great. You mentioned something about perception of workload. I'm not sure if you did touch on it, but can you explain a little bit more about that? So I was just really curious about what you meant by that. So do students perceive that the smart worksheets have a different type of workload associated with them?
Yeah, so I think it's that combination of the smart worksheets having the data analysis steps laid out. So not completely laid out from the start. So we use the function where students will do one part and then the next part's not revealed until they've mastered or they've been able to perform the bit before. So I think it's a combination of that and a combination of really being able to focus on something. So being able to focus on inputting the results into the table, taking the results from the table to build a graph, using the graph to, in most cases, do a linear regression to figure out a value. And I think those two concepts combined, I think, give the perception of the workload being much more manageable than staring at a blank screen and going, I have to write a lab report on the experiment that I did on Tuesday or whatever, and having to think about, I need to formulate an introduction, but actually I want to start doing my results so I know what numbers I'm getting out. But I should write down the methodology so that I remember the different things that I use and the different instruments and the different steps and stuff. So I think it's partly a consequence of the format of what the worksheet is in terms of having a degree of things laid out, but also the ability to have the students focus on a particular thing rather than kind of going, I've got the data, now I've got to write a lab report.
Absolutely. And I think particularly when you think about the pipeline that students come through to get to where they are now, when they go through schools, I think students are somewhat used to having things presented to them in a way that they can go through that sort of stepwise accumulation of knowledge and then presenting that knowledge. And I think it's useful for us to meet them in the middle and sort of help them, to utilize that thought process and that psychology behind how you actually perform and increase that knowledge at incremental steps throughout their work. So I think that's, really, really valuable. So thank you, Ben. Thank you for answering that question. So let me just check. There's something in the chat. I will just have a look. So Matt has asked a question. It's really insightful. Thank you. Picking up on the student comments about signposting on slide 16. Do you think it would be useful to have a more holistic experience? This would involve a platform or area where students are able to have a hybrid approach. So students will work through data, calculations, and reach conclusions based on those activities, and then have some sort of lab report style free text entry immediately after. I don't know what your thoughts would be on that. And that way they would be able to interconnect calculations and then their own prosaic interpretations. And then maybe the free text could be marked by an instructor. So I'm not sure if you got all that. Did you kind of get the gist?
Absolutely. That's it's a really interesting concept, actually. It's something that my one of my colleagues has looked into for a different practical course. So it's one that's not currently it doesn't currently use any online resources. So it's lab report or kind of written worksheet that the students use. But they're exploring that through our virtual learning environment. So to be able to kind of combine the ability for, I think it's more of a multiple choice type answer, combined with something that the students can then include some free text in answer to a question. Yeah, I think there's a potential that could be quite useful. I think one of the things that the advantage of using for us, I think the advantage for using the worksheet in the way that we do is the automatic marking. So the students don't really have that wait between when the students submit and getting the feedback on it. And the other thing is, as well as it being a bit of an assessment, as well as it being an assessment, what I also wanted to try and do is to try and use it as a way to kind of, in the background, teach students how to think about the numbers. And so being able to scaffold an explanation based on a number in the worksheet environment, I think lends itself towards that a bit more than saying you've calculated a number, now put some information in a box. I think that could be a next step, but I think in terms of this course as being our students' first introduction to a physical chemistry lab, so that their first year is a bit more of a general lab where they do a bit of everything. With this course being that introduction, I wanted the tie, I guess, or the connection between the number and what it means to be a bit more scaffolded, to get the students really thinking about, oh, well, if it is a negative, then what does that negative mean? And I can guide that, I think, a bit more in the worksheet environment in the way that I have done, rather than the focus on the free text. I think that would be useful for sure, but I think maybe in the next step or the next level up.
Yeah, okay, that's great. Thank you for the answer. And then there's another question by Chris. I'm not sure if we touched on this either, but he's asked, are the worksheets also being used to support pre-lab preparation?
So anecdotally, yes, students are accessing the worksheets before they go in to perform the experiment, so they have an idea of what it is that they are being asked about. So our pre-lab activities are formally or officially not the worksheets. So we have our own multiple choice quiz on our virtual learning environment. We ask our students to go through the cost and the risk assessment. They have some note taking that they do in their lab manual. But actually what I found is that students are using the worksheet, or they're going into the worksheet before the lab course, just as part of that pre-lab preparation, to make sure that they have an understanding of kind of what's coming up and what's the expectation. And that's particularly for the experiments that have, like that Beer-Lambert law experiment, where they have multiple readings for multiple different concentrations, being able to look at the worksheet to see what it is that they need to input later. Students are kind of thinking about the format of how they're going to take notes in their lab notebook based off of that exposure to the worksheet before their lab session. So officially no, but unofficially yes.
Okay, brilliant. And you're introducing different competencies as well, aren't you? With the way that they are thinking about how they can then even take in notes from other things, because they've been exposed to different elements in that smart worksheet.
Yeah, absolutely.
Which is great. Thank you. Any other questions? Nick. Hi, Nick.
Hi, Ben.
Nick Walker. Thank you.
Hi, Nick. How are you?
Thank you. Very nice talk. So one thing I wonder about is, of course, something at some point that we like our students to learn is also how you would structure the work that's involved in a data analysis. So I've lost count of the amount of times, for example, that I've been trying to organize a data analysis in my own work, and then halfway through setting up an Excel spreadsheet, I've decided to restructure it because I've realized I want them to go about it in a slightly different way, or I want to myself go about it in a slightly different way. So my question is, that process, the structuring of a data analysis, where is that taught within your curriculum? I guess with the worksheets, as you've described, students are guided through the process step by step. When do they make the jump to actually structuring their own work of that sort?
Yeah, so I mean, it's a really good point actually, and it's one of the things that I think we've partly done in this in the use of the worksheets in this lab course, but it's something that's extended a bit more in the third year lab course that they do the year after, which I also run. So I have a bit of an understanding of what they've done before and then what they need to do. So if I think about what they do in this lab course, so in that Beer-Lambert law experiment, I showed, albeit very briefly, the breakdown of the uncertainty calculation in particular, thinking about where each of the terms come from and how to lay out that calculation. What the students then have the opportunity to do, because of the way that each of the experiments runs and because of the fact that students will do four worksheets and 2 full lab reports, is that they will have an opportunity to do that same analysis for a different experiment for which they need to write a lab report. So a student would never do 2 uncertainty calculations laid out for them from beginning to end, if that makes sense. They will always have one where it's laid out for them on the worksheet, and then when they encounter it again, it would be in the context of one that they would then have to structure themselves, using what they've learned from the worksheet to try and help them with that layout if they so wish. But then that gets extended into the next year when the students are doing more complex experiments, much longer experiments. So in the third year, they're with me for 12 hours per experiment rather than 3 hours per experiment in the second year. And so there's a bit there that kind of allows that jump from that more structured data analysis to the one that's a bit more, free form or self-directed, I guess.
That makes a lot of sense. Thank you.
Great, thank you for that. Thanks for the question, Nick. And we have a question from Roy.
Hi Ben, lovely talk.
Hi, Roy.
As a
Thank you.
fellow physical chemist, I'm into searing brains. Don't worry. I was just wondering about how you mark the raw data the student actually supplies. I do a very similar experiment. Mine's using crystal violet, and I compare the student's data to data that was actually produced by a third-year project student. So they had a lot more time, a lot more replicates, so we know what they should do. But the other thing I do is I give them a mark based on their R² value. I saw a fair amount of scatter in the plot that you put up for us. I'm just wondering, have you incorporated that, or is it somebody with very scattered data that gets the right slope gets a high mark?
So I don't think off the top of my head that we give them marks based on their R². I don't know if Jason's in the call and also remembers.
Oh, much more gentle than me then. I'm being cruel and heartless, me.
I don't think we do, but so our practical mark, or our competence mark, I guess, based off of that final number that they calculate. So if we think about the Beer-Lambert law experiment that I showed you, that's based off of the second part of the experiment where the students have to calculate the enthalpy of vaporization of ethyl acetate, I think it is. So what I did there was I took all of last year's lab reports, figured out what the distribution was for the calculated results from the year previous, and then set up boundaries for what I would expect the students to be able to get using the equipment in the lab. So let's say I allocated 20 points for that percentage error between the experimental result of the student and the comparison to the previous year. Students would get, depending on what the distribution of the previous year's answers were, they'd get 20 marks if they were plus or minus 5%, 15 marks if they were plus or minus 10, etc. So the quality of data mark, or that I guess a component of that scatter, is contained within that comparison to what we would expect based off of all of the previous year's results.
Okay. Thanks for that.
Thank you there. That makes sense, because I think the actual skills that students are trying to demonstrate to us in the laboratory, sometimes they don't quite get it right. They don't quite get the data as tight as we would quite like them to be. So it's kind of, you know, you've got to meet in the middle somewhere, haven't you? You know, demonstrate that they're doing the best they can to produce as good a data set as they can, but with that critique as they're collecting the data. So that, I think that's the most important thing, isn't it? As you're collecting data, is this what I'm kind of expecting? Or is this, are they just doing any, you know, taking any of the data and then just accepting it and then trying to do a lab report with it? So we know skills is directly linked to quality of data, and therefore that directly linked to, you know, what you can construct from that and understand from that data. So it is a difficult balance, I think. Okay. Any other questions? Brilliant. Okay, well, we finished a bit early, which is great. Okay, so thank you for those of you that have joined. Thank you for those that have maybe watching this online, as you know, after the fact. And please, yeah, go to our websites, have a look at what's coming up next. I do have a little slide to show you who will be coming up next. So if you just bear with me a moment, and I always forget this, but hopefully my computer will allow me to share my. Oh, it's not allowing me to do it. Goodness me. Okay, wait. Here we go. I think it's this one. Yes. So thank you again for joining, everyone. Our next, I'm really excited to show that we've got two very talented teaching academics coming up. Dr. Christine Lockie, one of my colleagues from Warwick, and Stephanie Voiger from Northumbria University. Got a little bit of a gap between now and then, but please make every effort to come to see these. And it will certainly build on a lot of the things that you've already heard, especially from Ben today. If you want to sign up to any of the other smart worksheets, if you want to try some of the smart worksheets and sign up to any of the other webinars, please just use these QR codes and you can sign up. So I'm really looking forward to seeing Christine and Steph in the coming weeks. So thank you again for joining. Thank you for taking your time, Ben, for putting together your talk. It was a really great talk. And thank you to everybody who's contributed to the questions. We really appreciate it. That's it from me. And so if we can stop the recording, and for those of you that are joining online, feel free to please crack on with your marking if you need to. And hopefully we'll see you in our next webinar. So thank you very much and goodbye.
Thank you.